Bismillahirrahmanirrahim. Welcome to the third part of the seventh lecture of Statistics and Probability Theory. We will continue with the topic random variable as we have discussed in previous part that when there are two types of random variables, discrete and continuous. Something which we can count is discrete, something which we can measure in a given interval is continuous. If we talk about the distribution function, probability distribution of a discrete random variable is discrete probability distribution, and we have discussed example in previous part. We will continue with the cumulative distribution function of a discrete random variable. Cumulative distribution function is usually denoted by CDF for a random variable x is a rule or table that provides the probability x less than equal to k for any real number k. Cumulative probability is equal to probability that x is less than or equal to a particular value. In discrete probability distribution function, like we have discussed in previous part, that it was giving us the probability at some particular point, that is p of 0, p of 1, or p of x is equal to 1, probability x is equal to 2. In cumulative distribution function, we can find out the probability at some particular point, till some particular point, less than or equal to that particular value. For example, we can see here that x have 4 values: 0, 1, 2, 3, 4. As you can see, f of 0, f of 1, f of 2, f of 3, and f of 4. And we have the discrete probability distribution. We can say f of we can say here f of x, or also we can say p of x also. This one is 1 by 16. This one is 1 by 4. This one is 3 by 8. This one is 1 by 4. This one is 1 by 16. So, we can find out probability x is less than equal to x. This one is cumulative probabilities. Like the first one is 1 by 16. Next one is 1 by 16 plus 1 by 4. Next one is 1 by 16 plus 1 by 4 plus 3 by 8. Next one is 1/16 plus 1/4 plus 3/8 plus 1/4. Next one is 1/16 plus 1/4 plus 3/8 plus 1/4 plus 1/16. So by simplifying this, you can find out the CDF. So whenever you say the cumulative distribution function of a discrete probability distribution, so it could be the probability at some particular point. Like if we say probability, find out the probability x is less than equal to 1. So this would be equal to probability x is equal to 0 plus probability x is equal to 1. So this would be equal to 1/16 plus 1/4. So as we have defined that probability cumulative distribution function is probability x is less than equal to k. So here I have mentioned k is equal to 1. You can take x is equal to k is equal to 2, k is equal to 3 or k is equal to 4. So this one is complete cumulative distribution function. By simplifying this, you can find out the values or probabilities at less than equal to some particular point or less than equal to some particular value of x. If we plot the probability uh, uh, distribution of a discrete random variable, its CDF's graph, it would be stepwise. Like this one is probability x is 1, like the first value of the random variable, x is equal to 2, x is equal to 3. So this is the graph of the CDF. Minimum value would be 0 and maximum value would be 1. If you add all these values, these 1/16 plus 1/4 plus 3/8 plus 1/4 plus 1/16, it would be 1, as it would be the maximum limit of the CDF. This should be equal to 1. So you can find out by plotting these particular values. Like the first one is 1/16. So here would be 1/16. Next one, and plotting these cumulative distribution functions values, you will get the graph which is stepwise.